This video series goes through the daily problems in this maths calendar that is published by the American Mathematical Society. You can either purchase it through their website or via Amazon. Today's problem is to evaluate this expression here. Remember that if we have something to the power of a times the same thing to the power of b, that's equivalent to that something to the power of a plus b. Therefore, this expression is the same as 225 to the power of 1 on 200 plus 3 on 200 plus 5 on 200 all the way up to 19 on 200. Rather than perform this by hand, there's a fast way of computing it. Let S denote the sum that we care about, 1 on 200 plus 3 on 200 up to 19 on 200. Then S can also be written in the same way, just reversing each term. So 19 on 200 plus 17 on 200 plus down to 1 on 200. If we now add both this expression and this expression, we get that 2 times our sum is equal to 1 plus 19 is 20, 3 plus 17 is 20, all the way up to 19 plus 1 is 20. There are 10 terms in this expression. Indeed, formally, we can write S as the sum as n goes from 1 to 10 of 2n minus 1, all divided by 200. So there are 10 terms, so therefore 2s is 10 times 20 on 200. 10 times 20 on 200 is just 200 on 200, in other words 1. Therefore our sum is equal to 1/2. The quantity we need to find therefore reduces to 225 to the power of 1/2. This is just the square root of 225 by definition, which is 15. Why do we define something to the power of 1/2 as being the square root of that number? Well, it follows from wanting to maintain the rules that we already know are true. So we know that x to the power a all to the power b is given by x to the power of a times b. So x to the 1/2, whatever it is, should satisfy the property that x to the 1/2 when squared is equal to x to the power of 1/2 times 2, in other words x to the power of 1, in other words x. So if x to the 1/2 squared is equal to x, that means x to the 1/2 is equal to the square root of x.